Geometry Notes, Transformations, Section 4. We are going to be looking specifically at translations. But before we get into that, let's just review a little bit the different types of transformations. Transformation is when an image is changed in some way. This could be change in size, shape, or position. Following images have been transformed. So this figure here got moved to the right and up. This is a translation. This image here got reflected over this line of symmetry. This is a reflection. This image here was rotated to get this image down here. I'm using the terminology wrong. This pre-image got translated. This pre-image got reflected. This pre-image became this image. This one here, it's probably hard to see. There's a little fella right here, and it got blown up to this bigger size. So that is a dilation. We're going to focus on isometries right now. Translations, reflections, rotations are called isometries because the image is congruent to the pre-image. Also known as rigid motion. Translation, the focus on today. Key concept. A translation is a transformation that maps all the points in a figure the same distance and the same direction. The translation is an isometry. So point A moved to the right to get A prime, went up a little bit. B moved to B prime. C moved to C prime. Notice, which we've already discussed, those are all equal length. Also, they all moved in a parallel manner to each other. The diagram at the right shows a translation in the coordinate plane. Each point of the black square, and you probably can't tell at home, but this is the black one because your paper's in black and white. Each point in the black square moved 4 units right and 2 units down. 4 right, 2 down. 4 right, 2 down. 4 right, 2 down. 4 right, 2 down. Using the variables, you can see that each xy pair in the original is mapped to x prime, y prime, where x prime is x plus 4 and y prime is y minus 2. You can use arrow notation to write the following translation rule. The original figure had ordered pairs x, y. I would like to write above this pre-image. This became the image. This became x prime, y prime. Well, the actual rule for this specific example is that xy became x plus 4. We added 4 to each x value. Y became y minus 2. We subtracted 2 from each y value. That is how you write the coordinate rule. An example. Finding the image of a translation. What are the images of the vertices for triangle PQR for the translation xy becoming x minus 2 and y minus 5? Graph the image of the triangle. This is saying take every x value, move it left 2, take every y value, move it down 5. So if we go left 2, 1, 2, and down 5, 1, 2, 3, 4, 5, puts us right here as R prime. Left 2, 1, 2, and down 5, 1, 2, 3, 4, 5, right here is where P prime is. Q, left 2, 1, 2, and down 5, 1, 2, 3, 4, 5, puts us right here. So that we end up with this triangle, which theoretically is identical to the original one. Identify the coordinates of each vertex. So we could have did what we just did there. Algebraically, this is what it would look like. We're going to take every point, and we are going to subtract 2 from the x value and subtract 5 from the y value. So that would be 2 minus 2 and 1 minus 5, which would be 0, negative 4. This is p prime. And you can see p prime is 0, negative 4. So that checks out. 3, 3, you subtract 2 from the 3, subtract 5 from the 3. And you're going to get the ordered pair 1, negative 2 for q prime. Look at q prime, it's 1 to the right and 2 down. That checks out. R, we're going to subtract 2 from the x value, subtract 5 from the y value. It's going to be negative 3, negative 2. That's r prime. That's the left, 1, 2, 3, and down 2. So, checks out. Algebraically, graphically. The graph of the image of triangle PQR, to graph it, first graph points P prime, Q prime, and R prime, then draw the segments that make those up. Pretty obvious. There are 3 ways to write a translation. We could write it as point XY is going to become X plus A and Y plus B. Or you could write it as translation AB. Or you could write it as vector AB. Hold on 1 second. This translation here that you see here could be written how I just have it. It could also be written in parentheses. It can also be written using vector notation. It could be any 3 of those. On the quiz that you're taking, how did I have it written here? Quiz key, I had it written just like this. So you can leave it like that. You can use vector notation. Either one's fine. I'll be consistent in the notes with how the quiz is. So next example, we have a translation that moves point 4 units right and 3 units down. So we could write that using the algebraic rule, x plus 4, 4 units right, y minus 3, 3 units down. Shorthand for that is t, 4, negative 3, or the vector notation is 4, negative 3. Writing a rule to describe a translation. What is the rule that describes a translation of figure PQRS to P prime, Q prime, R prime, S prime? Well, just pick one of the points. I'm going to pick P, and I'm going to have to go to the right 1, 2, 3, 4, 5, 6, 7, 8 units. So that's plus 8. Then I have to go down 2 to get to P prime. So my rule is the ordered pair XY. I'm going to add 8 to the X value. I'm going to subtract 2 from the Y value. Or I could use the shorthand, T, 8, negative 2. Or I could use vector notation, 8, negative 2. 3 different ways to write the same rule. Example 3, graph the image of this using the rule 1 unit left and 2 units up, then write the translation rule. Let's first graph the pre-image. So C is 1, negative 2. A is negative 2, 1. T is negative 3, negative 3. Now, we can simply take this figure and we can say we're going to move this figure left 1 unit and up 2 units. And that puts us here. This would be A prime, C prime, T prime. Right, the translation rule, we don't have to use all the notations. We went left 1 and we went up 2. Write an algebraic rule to describe the transformation. Now when this is written in ordered pair form, just pick one of these points. Let's say that we choose this one here from C to C prime. How do we go from 2 to 0? Well, if we start at 2 and end up at 0, we had to subtract 2. How do you go from 1 to 1? Well, it doesn't change at all. So we're subtracting 2 from the x's and y stays the same. Let's just look through this and see if that works for this. Subtract 2, stay the same. Subtract 2, stay the same. Subtract 2, stay the same. That works. Example 5, same directions. Let's use a different notation for this. What's happening from 5 to 23? Looks like we're going to be adding 18 to it. From -2 to -16, maybe we're subtracting 14. So the rule is vector 18 to the right and 14 down. Does that work for all these? It sure does. Lastly, we have just some reviews of some algebra things maybe we haven't looked at for a while. Solving an inequality is the same as solving an equation, except for if you multiply or divide both sides by a negative number, this inequality sign changes direction. So I'm going to add 3 to both sides. I didn't multiply or divide by a negative number, so nothing changes. I'm going to divide both sides by -2. Since I divided both sides by negative, the inequality changes direction. X is less than -9. To graph that, find -9 on your number line. You can put it any place. Less than without an equal sign is an open circle. And then less than, we're going to shade to the left. Number 2, solve the equation. Well, I want to get simplify each side. There are like terms there and like terms there. So I'm going to get 2x minus 7 equals 3x minus 9er. I'm going to subtract 2x from both sides, add 9 to both sides, and I get x is 2. Factoring. If you're lucky, the lead coefficient of this is 1. It is not 1. Maybe you can factor 3 out. You cannot. This is the difficult type to factor. So here's what we do. We're going to split the middle term and factor by grouping. So the first term is going to stay the same. Last term is going to stay the same. But this middle term is going to get split into 2 separate terms. How do you split it? Well, let's use the MAN method. It's not really a method, it's just an acronym. We need 2 things that multiply to get the first term times the last term. 3x squared times -12 is -36x squared. We need the same 2 terms to add to get the middle term of 5x. So let's think. What are 2 things that multiply to get 5x, or multiply to get -36x squared and add to get 5x? How about the numbers 9x and -4x? Does that work? It does. So this middle term is going to get split, doesn't matter the order that you write this in, as a positive 9x and a -4x. Once you've split the middle term, which we just did, now we're going to factor by grouping. Let's group the first 2 terms together and the last 2 together. What's the GCF of this first group? Well, it's 3x, leaving us with x plus 3. What's the GCF of the second group? Is a -4, leaving us with x plus 3. Now, each of these terms has a common factor of x plus 3. So if we pull that out to the front, distributive property, we're left with a 3x minus 4. So we factored it. If you're not sure when you're done if it's right, multiply it out and see if you get the original. Number 4, this is a difference of two squares, which easily factors into the conjugates. Square root of x squared goes in the first position, square root of 9 goes in the second position. Equal 1 plus and 1 minus, doesn't matter which is which. Graph this equation. In general, we like to have it in slope-intercept form. We're going to multiply each term by a half. I'm going to also write it so that the x term is first. Y-intercept is 1. I have a slope of negative 1/2. I go down 1 to the right 2, or I go up 1 to the left 2. Please label the y-intercept. Make sure you have arrows on your lines. Number 6, we could put this in slope-intercept form, but since it's in standard form, maybe it's easier to just graph this by using the x-intercepts. Both the intercepts, x-intercept and the y-intercept. To find the x-intercept, where it crosses the x-axis, you put 0 in for y. Because any place on the x-axis, the y value, 0. So that's 3x plus 2 times 0 equals 12. So 3x is 12, x is 4. This crosses the x-axis at 4. To find the y-intercept, you put 0 in for x, and you get y is 6. This crosses the y-axis at 6. Please label the y-intercept. Connect your points with your company-issued straight edge. Done. Please do the assignment for T4.